Hi, I am Gautam and welcome to Easy. In this video, I am going to talk about a new important topic, isomorphism. Okay, so what is isomorphism? Isomorphism, if we break it and get isos, ISOS and morphy, right? So isos means equal and morphy means form. So what we get? Equal form. So what is isomorphism? There are many ionic compounds actually, not covalent compounds. Okay, so there are many ionic compounds. Those are maybe crystalline or liquid form. They may stay in the right. So when they crystallize, crystal forms simultaneously. Okay, and those pair of compounds, suppose two different ionic compounds form crystals in the same form, then these two crystals or maybe three crystals also present, but maximum time there are two crystals present and they form same crystals, same type of crystals or same form. They are in the same form, right? So just these two type of crystals are called isomorphous crystal. Okay, similar like isomers, there are some compounds, those have similar formula but different geometrical configuration. For example, similar formula but they have something like ether, maybe ether or alcohol or ketone, something like that. Okay, so just they may form ether or alcohol or ketone. Just those three are corresponding isomers, and here also those two or three are isomorphous crystal. Okay, so let's and this phenomenon is called isomorphism. This crystallization simultaneously. So in one line, isomorphism is the phenomena in which crystallization of more than one compound occurs simultaneously. Okay, so let us consider an example. Suppose AX is an ionic compound and BY is an ionic compound. So when we in the liquid, suppose they are both in the liquid form. Okay, so when and they are mixed. Okay, so when we keep it in a vessel and let it to be crystallized, then a crystal will form in which both of them will present. Okay, suppose this forms FCC and this also forms FCC. So these two will form FCC crystal and in which these and these both are present. Okay, so this is why isomorphous crystal forms, right? So here one point is important, that they may co-precipitate. That means AX and BY may form precipitation simultaneously. Okay, so let us consider a real example. Okay, so first we are considering some example. For example, NaNO3 CaNO3, this pair, then another pair, say KClO4 and KMnO4. This is another pair, and say one last pair, a big system, ZnSO4.7H2O and MgSO4.7H2O. These and these forms isomorphous crystals, these and these form isomorphous crystals, these and these forms isomorphous crystals. Okay, so to form isomorphous crystals, there are they should follow 6 conditions, right? So what are the conditions? The conditions are, they should have, number 1, they should have same type of formulas and same number of ions or atoms. So same types of formula and same number of atoms or ions. Okay, I am explaining all of this later. Just first let me tell you the different 6 conditions. Okay, so second condition is their size, that is size of this atom and this atom and this atom should be comparable. Size comparable. Okay, so third condition here is their stereochemical orientation should be same. So what is stereochemical orientation? Suppose there is one atom and those atom shows sp3 hybridization in that particular atom. Suppose let's consider NO3 minus, and we are considering N atom. So here also we are considering N atom. So NO3 minus, NO3 minus both have same same hybridization, and that is why both will show similar kind of structures. Okay. Thus, they should have similar stereochemistry. Okay, that is three-dimensional chemistry. Now, next coming to fourth, that is polarizing power and polarizability should be same. So, which shows polarizing power? The cation, that is Na plus here, and the polarizability which shows NO3 minus. So, and here also calcium 2 plus and NO3 minus. So, polarizability of NO3 minus and NO3 minus both are same here, so there is no distinction between them. But Na plus and Ca2 plus, these two should have similar polarizing power, right? Okay, so the fourth factor is polarizing power. Factor 5. What is factor 5? Similar crystal structure. That is, if one shows FCC lattice, then another should show FCC lattice. If one shows BCC lattice, another need to show BCC lattice. Okay, so both have similar crystal structure. And next, point 6, which says they should have comparable molar volume. What is molar volume? It's actually the volume of 1 mole of that compound. So this ionic compound should have the same molar volume as this ionic compound. Okay, so these 6 conditions should be followed to show isomorphism. Okay, so let us consider the first case, that is NaNO3 and CaNO3. Okay, NaNO3, CaNO3. The molar volume of NaNO3 is 37.4 and for CaNO3 it is 36.9. So both are nearly 37. So their molar volume are comparable. Okay. So next coming to radius of Na plus, which is equals to 95 pm, and radius of Ca2 plus, which is equals to 99 pm. Here also the cation, here Na plus, here Ca2 plus, both cation has similar kind of radius. And then coming to NO3 minus ion, each NO3 minus that shows sp2 hybridization. Here also NO3 minus shows sp2 hybridization. How does it looks like? NO3 minus. Okay, O plus minus minus. So it is trigonal planar. So both have similar kind of structure. And finally, the radius ratio, that is R plus by R minus for NaNO3 is nearly same as R plus by R minus of CaNO3. So thus all the parameters of these 6 conditions should be same. Then they will be isomorphous to each other, right? As we know the definition of isomer, that is, there should have similar formula but different geometrical configuration. But here they should follow the 6 conditions, and thus they are isomorphous to each other. Okay. Next, coming to another 2 example, that is NaNO3, and we are changing calcium as KNO3. Just changing the calcium ion by K. Okay. So here NO3 minus is common. So with cation we have no issue. So we have issue only with the cation, right? So Na plus, which has the radius Rna plus equals to 45 pm, 95 pm, and K plus has the radius equals to 133 pm. Okay, so now the radius ratio R plus by R minus of NaNO3 is not equal to R plus by R minus of KNO3, because NO3 is common, so its radius is same, but Na plus and K plus, the radius of K plus is greater than Na plus, so this radius ratio will not be same, so they will not isomorphous to each other. Okay, so they will not co-precipitate or they will not form crystals simultaneously. Okay, So these are not isomorphous. So these two do not show isomorphism. Okay. So now taking another example, but quite different. Say BaSO4 and KMnO4. Okay. Radius of BaSO4, that is Ba2 plus radius, is 135 pm. Radius of K plus, which is 133 pm. Both are quite similar. SO4 minus shows tetrahedral structure. MnO4 minus shows tetrahedral structure. Sulfur atom is in sp3 hybridization. Manganese atom is in sp3 hybridization. Also, R plus by R minus of, that is radius ratio of BaSO4, is quite similar or nearly similar with KMnO4. That is why both shows isomorphism, and KMnO4 and BaSO4 are isomorphous to each other. Okay, and that is why they will precipitate simultaneously, or they form crystals simultaneously. I hope these three examples clear your concept, right? If you have any query, please comment below and let me know what is your problem, and I will definitely help you. Okay, so thank you. Thanks for watching.